let's talk a little about references and constructors. First, let's talk about the difference between objects and primitive data types. When we have primitive data, and by primitive data I'm referring to types like int and double, they're stored in a fixed size in memory. Strings, on the other hand, are not fixed in size. So you see two strings below. One, I have lots of characters and need lots of space, and the other, not me. These two strings are stored in different amounts of memory. The longer string takes more memory, and the shorter string takes less memory. So a fixed size memory doesn't work for strings. Now, sometimes also with strings, the size isn't known until the program runs. So for example, when you read a string in from a scanner object, you don't know if the user is going to enter 1 character or 1,000,000 characters. So the differences in the size of strings can be extremely large. This is why strings are an object instead of being primitive data in Java. Objects in primitive data are handled differently. Now, a lot of it looks the same, but it has different meanings. And so one thing that I want you to understand is the difference in meaning between how objects are handled and how primitive data is. So here's how objects work in Java. Objects are stored on the heap. Now, what the heap is a glob of memory that's reserved for use by a program while it's running. Anything that's allocated with new is always stored on the heap, so there can be a lot of memory on the heap. The reference is an address where an object is stored on the heap. And references get identifiers. Remember, when we had primitive data, we used an identifier to refer to its location in memory too. But there's a little difference here that you'll see when we draw the memory diagrams. So let's declare and construct an object. So string name, this creates a reference name, which will hold the reference for a string object. That's what it looks like in memory. Now at this point, the reference is null. What I mean by null is there is no object attached to it yet. So if you tried to do something with the string name at this point, it's not going to work. The way we show this in a memory diagram is by putting a slash through the box. A slash through the box doesn't mean anything with primitive data, but with objects, what it means is the reference is null. That is, that it's not a legal reference and there is no object attached. When we construct a string, so we'll do name equals new string, and then double quotes Sadie. This constructs an object on the heap, so that's what that looks like. And then it stores the reference and location name. So now instead of having null in it, name is going to have the address of the string object Sadie. Now sometimes I show addresses when I'm doing this. For some people this makes a lot of sense, and for other people they find it confusing. I don't care which way you do it. The address that I'm showing there is completely arbitrary. I usually choose numbers between 1 and 999, but it could be anything you want. So 235 doesn't mean anything. It just is the address in memory where this particular string happened to be located. And the 235 is what's stored in the box. Sometimes understanding that can really help make more sense out of these memory diagrams. So let's make a comparison. When we have int length, this is what it looks like. Now int is a primitive data type, so we're not going to have any arrows coming out of this box. When we say length equals 3, 3 goes in the box right there. With a string, on the other hand, we'll say string size. Now that creates a reference called size. And here's where things start looking different. When we say size equals new string, double quote ABC, double quote, this is what happens. We get a new object that's allocated on the heap, and its reference is stored in size. We show that by putting an arrow between the box which contains size and the string object on the heap. Now, let's suppose we say size equals DEF. Now this one is kind of tricky because double quote DEF double quote is a hidden constructor. This is one of the sneaky things that Java does that I really wish it didn't do, at least for beginning programmers. So this is actually the same thing as calling a new string constructor. So what's going to happen is we're going to get a new string object, and its reference is going to be put into the box labeled size. Now notice at this point, the box labeled size doesn't refer to the string ABC anymore. That string now is sort of loose in memory. Eventually it will go through something called garbage collection. When Java runs out of memory, it runs around and picks up all the leftover memory that you've left wasted at the side and reuses it. Now most of our programs are so small that there isn't any real garbage collection going on, and garbage collection is very much not under the control of the programmer. Java actually has some methods in it that pretend that you can control the garbage collection, but the truth is they usually ignore what you're doing if you look at the code. So at this point, the reference size points to the string DEF. The string ABC has been abandoned. Even if we wanted to use it in the future, we can't get back to it because we don't have its reference anymore. So you can think of objects as being a little bit like helium balloons, in that if you release the string, up they go, they're gone. It's not that they're not there, they're still there, but you can't get to them. So keeping track of references is very important. So let's make some observations. There are subtle differences between the storage of primitive data types and objects. For example, we have to construct objects, whereas we don't construct primitive data types. The constructor, remember, is what we call when we call new. Objects are on the heap, not in the stack frame like the primitive data usually are. And objects have references. Now, what this all means when you put it together is that parameter passing is going to work differently. So this is going to have some very important consequences shortly. Keep programming.